We are starting sequences and series today, but first, before we can even go over anything about them, we need to figure out what they are. So I have your definitions for you. A sequence is actually a function, so there's going to be an equation whose domain is a set of consecutive integers. And if a domain is not specified, it is understood that the domain starts with 1. So if a domain is not specified, it's understood that the domain starts with 1. So it's really just a list of numbers. 1, 2, 3, 4, and so on and so on. Okay? So our domain is just really what number the term is. Is it the first term, the second term, the third term? 1, 2, 3. It always starts with 1 unless they tell you otherwise. The values in the range are called the terms of the sequence. Okay, so the actual terms of the sequence are what gets spit out when you plug in 1, 2, 3, 4, 5. Okay? So for example, or this is a general example, your domain is almost always going to start 1, 2, 3, 4, all the way to n. N is the general term, the general equation. Our range, or the terms of the sequence, we label them A sub 1, A sub 2, A sub 3, A sub 4, all the way to A sub n. Okay, this is also called the second or the first term of the sequence, the second term of the sequence, the third term, and if it's just in general terms, the nth term. Okay, so if I don't know what n I want to go to, we call it the nth term. Okay? We have two types of sequences. A finite sequence, which has a limited number of terms. So for example, just a list, 2, 4, 6, 8, that's finite. It starts with 2, it stops at 8. An infinite sequence goes on forever without stopping, and it's different because we list 2, 4, 6, 8, and then has the dot, 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 which means it goes on forever. So that dot, dot, dot means that it goes on forever. It's an infinite sequence. A finite sequence eventually just stops. It's just a list of numbers. Okay? These are called the terms, remember? This is the first term, the second term, the third term, the fourth term, and so on and so on. Okay? So example 1. All they want us to do is write out the first 6 terms of each sequence. This is the equation for the sequence. And then remember how in the CST review stuff that we were doing, when if they gave us a list like this, I just told you to label them n equals 1, n equals 2. Remember that stuff? That's what this is. So the n equals 1, that's your domain, the number term. The 2, that's the range, the answer, the actual term. Okay, so what we're going to do here, for example 6, they want us to write out 6 terms of the sequence. So we need to find A sub 1, which, what are we going to plug in for n? 1. So 1 plus 4, which gives me 5. So the first term, A sub 1, of this sequence is 5. What's A sub 2? 2 plus 4, which gives me 6. Okay, so the third term, A sub 3, would be 3 plus 4, which is 7. A sub 4, 4 plus 4, 8. A sub 5 is 5 plus 4, which is 9. And A sub 6, 6 plus 4, which is 10. Okay, easy enough, right? Not too bad? Number 2 is almost exactly the same. They list your terms a little bit differently. F of n, it's the same thing. So we're going to start with f of 1. That's negative 2 to the 1 minus 1, which is negative 2 to the what? 1 minus 1 gives me 0. And anything to the 0 is 1. So then we need to find the next 5 terms. F of 2 is equal to negative 2 to the 2 minus 1, negative 2 to the 1, which is negative 2. Okay, what about f of 3? Negative 2 to the 3 minus 1. Negative 2 to the second. What's negative 2 to the second?
4.
4. What about f of 4? That's negative 2 to the 4 minus 1, which is negative 2 to the third. What's negative 2 to the third? Negative 8. F of 5 is negative 2 to the 5 minus 1, negative 2 to the fourth. Negative 2 to the fourth is positive 16. And then last one, negative 2 to the 6 minus 1, which is negative 2 to the fifth, which is negative 32. Okay, so all I'm doing is taking the number term, first term, second term, third term, fourth term, and plugging it in for n, and that's going to give me the actual value of the term. So 1, 2, 3, 4, 5, 6, that's the number that the term is. Is it the first term? Is it the second term? Is it the third term? What is the first term? Well, I have to plug in 1 and get the answer. Okay. What's the second term? I plug in 2 and get my answer. So my second term is negative 2. My third term, f of 3, or a sub 3 sometimes, is positive 4. We just plug in 3 and get our answer. Okay, does that make sense, guys?
Yep.
Okay. Oh, let's try number 3. I need to find the first 6 terms here, so give yourself a little bit of room because of the fraction. The first term is a sub 1. That's 1 over 1 plus 1, which is 1 over 2, or 1 half.
That's your answer, right?
And that's your answer, yeah.
Okay.
So the first term is 1 half. What's the second term? A sub 2. 2 over 2 plus 1, which is 2 thirds. So your second term, a sub 2, is 2 thirds. This is just the label of the term. So what's your third term? 3 over 3 plus 1, which is 3 over 4. You guys see the pattern for this one? A sub 4 is 4 over 5, a sub 5 is 5 over 6, and a sub 6 is 6 over 7. It's just plugging in for right now. This time, I'm giving you the terms, and I want you to figure out the pattern, give the next term, and then write the nth term of the sequence, which means write the equation for the sequence. How can I find the 100th term? Okay, I can by just plugging in 100. Okay, so what we have to do for these is the first thing I always do is label them. N equals 1, n equals 2, n equals 3, n equals 4. It always starts at 1 unless they tell you otherwise. So you can always assume that it starts at 1. So we're given 1, 2, 3, 4 terms so far. I want you to find a sub 5, the next term, and then we also want to find a sub n, the equation in general terms. So let's look at this. What are some things you notice? It's going to be negative for sure, right? Okay, so we know it's going to be negative for sure. So I'm going to put a negative here and a negative here. I know it's negative for sure. So what we have to do is we need to look at the number term, 1, and how can I get 1 to turn into negative 1?
Negative 3. Right? This is negative 3.
It is. How can, but let's for everybody else. Okay, what are some ways that we can turn 1 into negative 1?
Multiply by negative 1.
Multiply it by negative 1. Okay, so let's try that for 2. What's 2 times negative 1? Negative 2. Does that give me negative 8? No, so that's not going to work. So is there any other way? Let's maybe look at 2. How can I turn 2 into negative 8? 2 to the third power. 2, you could do 2 times negative 4, right? Let's try negative 4. What's 3 times negative 4? Negative 12. That doesn't work, right? And it doesn't work with 1 either. But let's try Madison's idea. What about 2 to the, or negative 2 to the third? What's that going to give me? Negative 8. What's 1 to the third going to give me? 1. What's 3 to the third going to give me? 27. What's 4 to the third going to give me? 64. So what's 5 to the third going to give me?
625.
Not 625.
125.
125. So how can I write that in general terms? We know there has to be a negative out there. What was I doing? I was taking the n, right, the number term, and raising it to the third power. So negative n to the third. Unfortunately, right now, it's guess and check.
But is there a
Okay?
method to do it?
There will be a method. Right now, we're guessing and checking. Okay, so I could ask you, what's the 100th term, and what would you plug in for n? 100, and you would be able to get the answer. Okay, so that's what we're doing here. So let's look at B. First thing I want to do is label n equals 1, n equals 2, n equals 3, n equals 4. I want to find a sub 5 and a sub n. So how can I get 1 to turn into 0? Multiply by 0?
But then everything is
But then everything should be 0. Well, what's the pattern? What do you guys notice about the pattern? They're all even. Yeah, it goes up by 2, and then this one increases by 4, and this one increases by 6, so this one would increase by 8, so what would this term be? 20. So how can we write that in general terms? What do you guys notice? They're increasing, each one is increasing by how many more each time? By 2, right? So this is telling me that it's going to be the number squared. So we're looking at something squared. So I know there's going to be an n squared in there. Because every time we're adding by the previous plus 2, we'll talk about this when we look at more general terms. So n squared, so let's look at that. I'm going from 1 squared. 1 squared gives me 1. I need it to be 0. So what can I do? Obviously it's not just n squared, right?
minus 1.
I can subtract 1. So 1 squared minus 1 gives me 0. 2 squared gives me what? 4, but I need it. Thank you. I need it. She's not here. 2 squared gives me 4, but I need it to be 2. So what do I have to do there? Subtract 2. 3 squared gives me 9, but I need it to be 6, so I'm going to subtract 3. 4 squared gives me 16, and I subtract 4. So this is n squared minus what?
No.
Not n squared. Minus the term, so minus n, right? N is the term. So I take whatever number term it is, I square it, and then I subtract the original term. So n squared minus n. Does that make sense? So we figured out what a sequence is. A series is a little bit different. Okay? When the terms of a sequence are added together, the resulting expression is a series. So a series is when we take the sequence and we add it all together. The sequence is just the list of terms. The series are actually the sum. You just add them all together. Okay, we have a finite and infinite series as well. Finite means I just take the terms 1, 4, or 2, 4, 6, 8 and add them. Infinite means I'm taking the terms 2, 4, 6, 8 and I'm adding, and I keep adding forever and ever and ever. So infinite has ... Finite is just stops. Okay? We have a different type of notation for series and their sums. It's called summation notation, which is kind of fun to say because it rhymes. For example, what it is we take the Greek letter sigma, which is the big E. It means, in math, it means sum. So it means whatever we're taking, you're adding it all together. I equals, that is where we're starting. So this is your first term. Okay, so the I equals, that's your first term. They're telling you we're starting at 1. Okay? The number on top is your last term. So they're telling you where to start or where to stop. So for the sum, they're saying I want you to start at the first term and add them all up until you get to the 4th term. And then inside is the equation or the rule. How do I get each term? Okay, so this is what we had just practiced finding. Now we're going to take them and add them all together. We read this as the sum from 1 to 4, because that's where we stop, of, and then your rule, 2i. Okay? Now we've been using n's before. For series we use i's, but it's the same idea. They're going to give this to you. So we read this as the sum from 1 to 4 of 2i, so of the rule. This one we would read the sum from 1 to infinity, because it goes on forever, it's infinite. The infinity symbol is a sideways 8. So the sum from 1 to infinity of 2i. So what we're going to have to do for 6, 7, 8, and 9 is we need to figure out the rule and then write this sum in summation notation. We're only going to do 2 of them because we're going to run out of time. Okay, we'll finish these tomorrow. So let's look at number 6 right now. I need to figure out the rule, which means first I'm labeling 1, 2, 3, and then I don't know what term this is yet because I don't know what the rule is. Does anybody think they have the rule?
It's all added by 5.
It's all being added by 5. How can I get 1 to turn into 5 though?
Plus 4.
Plus 4. Would 2 plus 4 give me 10 though? No. What's another way?
Times by 5.
Multiply by 5. 1 times 5 gives me 5. 2 times 5 gives me 10. 3 times 5 gives me 15. So what term is this? What times 5 is going to give me 100? 20. So this is the 20th term. So I want to write this as a sum. So this is the sum from 1, so I equals 1, to what? How many? So to 20, so 20 goes on top, of, what's the rule? 5 times I. Okay? What about number 7? Here's 1, here's 2, here's 3, here's 4. This one, is it stop or does it go on forever? It goes on forever. So let's start writing the sum from 1 to infinity of, what's the rule? Well, I know it's,
Why don't you put 1 half?
because this is still the first term. The rule is just a fraction. It's like the third one where we were listing all of the 6 terms. It came out as a fraction. So let's look at the numerator first. How can I get the numerator? 1 to the second power is 1. 2 to the second power is 4. 3 to the second power is 9. So this would be I squared. So how can I get the denominator? What do you notice? It's I squared plus 1. It's the same as the numerator, but you're just adding 1, right? 4 plus 1 is 5. 9 plus 1 is 10. 16 plus 1 is 17. So the bottom is I squared plus 1. So that's your summation notation. So number 10, the sum from 1 to 5 of 8i. I want you to find the sum of the series. So that all we're doing is plugging in and adding. So we have to start with the first term, 8 times 1, plus the next term, which is 8 times 2, plus 8 times 3, plus 8 times 4, and we stop at 5, so plus 8 times 5, and we stop. This is 8 plus 16 plus 24 plus 32 plus 40, and then we want to add all of those together, which gives me 120. So that's all you have to do. They want you to find the sum.
Okay.
Number 12, look at it really quick. I have the sum from 1 to 34 of 1. Any ideas of what that would be? I'm adding 1 how many times?
34 times.
34 times. So what's the answer going to be? 34.
Oh.
Okay.
What's
Tricky.
Number 11.